if you have a quadratic formula, well, we say x is equal to negative b plus or minus b squared minus 4ac over 2a. Note, b squared minus 4ac is called the delta. Delta or discriminant this is of particular importance because this dictates the nature of the roots. Now, if b squared minus 4ac is equal to 0, then the roots of that equation are real and equal. Now, if you have your Cartesian plane there, your root will of course this can be like that. And if this point here is a 2, point is a 1, what is it? 3 minus 1 minus 2 minus 1 here minus 2 then. That's a 4 there, 2, 4, 6. This R can be given by the function x for x plus a 4. This is x squared plus a 4x plus a 4. If we leave this equal to 0 and look for the x-intercept, which is of course the roots, or what we call the zeros, so the x-intercept, the x value, when y equals to 0, the x-intercept will be x minus 2 into x minus 2. These are the factors of that equation up there. So here I will have x minus 2 is equal to 0 or x minus 2, which is equal to 0. Therefore, x transposing that will be a 2 or x. I hope you appreciate that we have x is equal to a 2, x is equal to a 2 there, and then your a is positive here. That's what we have. Positive there, function is facing up because A is positive. Now, if A is negative, we can draw yet another Cartesian plane we can get the function function can be that. This can also be a 4 here, a -2 there. Now, g of x, the function here can be g of x, which can be given by x squared plus 4x plus a 4. Now, in this equation, this can be compared to a quadratic equation there, which means here we have A is equal to 1, B is equal to a 4, and C is also a 4. That's our B there. That's our A here, our B there, our C. So that's what you have as my C is a 4. Now A is the coefficient of x squared, while B is the coefficient of x, and C is a number that is independent of x, and that gives us the y-intercept. As you can see, C here is 4, and the y-intercept is 4 there. Now, if we have to factor this equation out, we have x squared plus 4x plus 4. This is x plus 2 into x plus 2. So x plus 2 is equal to 0, or x plus 2 is equal to 0. Therefore, x transposing that positive 2 becomes a -2. Transposing that 2 becomes a -2. Now, x is a -2 there. Now we can test the value of the discriminant, which is our delta, which is b squared minus 4ac. Testing that, that will be, our b is a 4, that will be 4 squared minus 4. Our a is a 1, our c is a 4. 4 squared is 16. -4 times 1 is -4. -4 times 4 is -16. 16 minus 16 is 0. So you have the value of your discriminant being equal to 0. as we stated here, that if the discriminant is equal to a 0, if the value of the discriminant is equal to a 0, therefore the roots are real and equal. You see, the function touches at only one point there. Now let's have a look at what happens when the value of the discriminant being less than 0. The value of the discriminant being less than 0, which means it's negative. If you draw that, you have 1, 2, 3, minus 1, minus 2. So it's less than 0. It goes there, it means it's negative. Therefore, meaning that b squared minus 4ac is less than 0. This implies that the roots are non-real. The roots are non-real, or we say they are imaginary. Imaginary roots. And if a is less than 0, they go down. And then if a is less than 0, you see that you said the roots are the x-intercept. There is nowhere where that function intercepts the x-axis. See, that's what you have. Let's go and have a look at the next one, where the value of the discriminant is greater or equal to 0, and is a perfect square. If is a perfect square, the roots are real and rational. The roots are real and rational. Now, let's have a look at the fourth one. The value of the discriminant is greater than 0 and an imperfect square the roots are real and irrational. Now let's have a look at a few examples where we are given an equation and we are required to determine the nature of the roots. 1. A given x squared plus a 9 is equal to 4x. The best thing is for you to write that equation in standard form. Ax squared plus bx plus c now we said the discriminant is the one that gives us the nature of the roots, which is b squared minus 4ac. Now, that is equal to writing down that a is equal to 1 there, b is negative 4, and c is negative 9. So if you put b squared here, it's going to be negative 4 squared minus 4. A is a 1. C is of course a 9. Negative multiplied by negative is a positive. 4 and 4 will be 16 minus 36. The answer here will be negative 20. Now, the value of the discriminant is less than 0, which means the roots are non-real. The value of the discriminant is less than 0. Therefore, the roots are non-real. So you can conclude that the roots are just imaginary. So because A is positive, the function will look like that. The function will never touch the x-intercept. The function will never touch the x-intercept. Let's look at the next one. The next one says 4t squared minus 19t is equal to 5. Now this is 4t squared minus 19t minus 5 is equal to 0. Obvious that A is a 4, B is a minus 19, and C is a negative 5. Now, we need to write down the discriminant. Discriminant, which is b squared minus 4ac b squared minus 4ac. Our b is negative 19, so minus 4. Our a is a 4. Our c is a minus 5. 19 squared is 361. Negative multiplied by negative is positive. 4 times 4 will give us 16. 16 times 5 give us an 80. 361 plus an 80 give us 441. Now, the square root of 400 is 20. But now, do you have the square root of 441? Square root of 441 will be 21. Therefore, this is 21 squared. That is a perfect square. Now we can conclude that here the nature of the roots is that such that the roots are, they are real, of course, and rational. They are real and rational. Now let's factorize that expression and see what our roots will look like. We will have 4t squared minus 19t minus 5 is equal to 0. The roots of 40 is 40 and t, or 2 and 2. 2t multiplied by 2t, let's give us 4t squared. 5 is 5 and 1. You write 5 here, write 1 there. If I multiply that, I get 20. The difference is 1, so we better take this one here and write that one as a plus. So it's going to be 4t plus 1 into t minus 5. That is equal to 0. So 4t plus 1 is equal to 0. Or t minus 5 is equal to 0. T will equal to 5. Here, 4t will equal to negative 1. Therefore, t will be negative 1 over 4, or t is equal to 5. So, those are the roots. You see that it's true that they are rational. This can be written as 5 over 1, which is 5, of course. Let's go to the next one. The next question here says, consider the equation k is equal to x squared minus 4 into 2x minus 5, and x is not equal to 5 over 2, because if x is equal to 5 over 2, the denominator will be 0, and division by 0 is not allowed in mathematics. So this can be 0, and it's only possible for it to be 0 when x is 5 over 2. So we say x is not equal to 5. Restrict that. Now, I hope you appreciate that this can be written as x squared minus 4, 2x minus 5 is equal to k over 1. Cross multiply that by that, cross multiply that by that. Why? Because if you have 1 over 2 is equal to 4 over 8, if you cross multiply here, you get 8. If you multiply there, you still get 8. So, multiply by 1 will be x squared minus 4 will equal to k into 2x minus 5. Now, this can be written as x squared minus 4 is equal to 2kx minus 5k. Transposing everything on the to the left, we have x squared minus 4 minus 2xk plus 5k is equal to 0. Try to rearrange this monster into ax squared plus bx plus c will look like x squared, and then this will be negative 2x plus 5k minus 4 is equal to 0. Now, be careful. Hope you realize that this term here and that is independent of x, therefore it qualifies to be our c, and then there's our x, so this will be our b. B is the coefficient of x, and our a will be 1. Now, they say you consider the equation such that it has equal roots, and then number 1 says equal roots, number 2 says rational and unequal. Now we want to know what will be the value of k such that this equation has equal roots. For equal roots, b squared minus 4ac should equal to 0. Our b is going to be negative 2k squared minus 4, a is a 1. Our c is 5k minus 4 is equal to 0. Now, this will give us 4k squared. This will give us 4k squared. 4k squared. 4 times 5k is minus 20k plus 16. That is equal to 0. But 4 can go here. You can divide right through by 4. If I divide right through by 4 to make that equation to look better, this will be k squared minus 5k plus 4 will equal to 0. Now we look at the first one and the last one. The factors here will be k multiplied by k If you multiply these two, you get the first one, and then that will be 4 and 1. Negative and negative will give you a positive. So k minus 4 into k minus 1 is equal to 0. Therefore, k minus 4 is equal to 0, or k minus 1 is equal to 0. K is equal to -1. Here, k is equal to a 4. Therefore, for the roots to be equal, k should either be 4 or -1. The last one was that the roots should be rational and equal. If the roots are rational, it means that the value of the discriminant is greater than 0 and is a perfect square. And is a perfect square. Now let's see. It's a perfect square. Now, therefore, b squared minus 4ac must be greater than 0. Therefore, we can go and have a look at our discriminant there, which was which had worked out to that equation there. From this, it was 4k squared minus 20 divided by right through is k squared. That is the value of our discriminant here. K squared plus minus 5k plus 4. That was k squared minus 5k plus 4. Know that the roots here were k minus 4 into k minus 1 is equal to 0. Now, realize that we have an inequality. We need to exercise some caution because a times b is greater than 0. Either they are both negative or both positive, because negative multiplied by negative is positive, is more than 0, or positive multiplied by positive greater than 0. Let's look at the first instance. The first instance where they are both negative, it means k minus 4 is less than 0, and not or, and at the same time, k minus 1 is also negative. Now, see, k here is less than 4, and k here is less than or equal to 1. Now, on your graph, you write 0, 1, and 4. If k is less than 1, it is also less than 4. So we take that. Now, the second case will look like k minus 4 is positive, and k minus 1 is also positive, where k is greater than 1, where k here, not x, is greater than 4. If you are more than a 4, you are also more than a 1. So you take that one because this factor is included in that. So for this to be a perfect square, it must be equal to 1 or less than 1 or equal to 4. and is equal to n greater than 4. I hope you see this. That's the end of the lesson.